let's look at the steps to calculate a test statistic and a p-value. In order to win an election, you need to get more than 50% of the vote. A sample of the voters was polled to see if you are likely to win, and the sample of 500 random likely voters finds that 51.6% are planning to vote for you. Calculate the test statistic and the p-value. So as we already saw on this problem, the null hypothesis for this is that our proportion that's voting for us, P, is 50%, but we're trying to find evidence of the alternative, where P is greater than 50%. So when we're trying to find what we call the test statistic, we're just trying to see how far away was our data that we observed, which yielded this statistic right here, compared to what we expected to see. Well, what do we expect to see is the null hypothesis, because this is what we're assuming is true. So we're just trying to see how far is that away in standard deviations. It's a z-score. So using the formula for a z-score, it's our observation, right? Our score, which is the p hat, minus what we expect to see, our mean, p, from our null hypothesis, which we annotate as p naught. And it's over the standard deviation, which in this case would be p naught, q naught over n. So substituting all these values in, we can calculate how far away our value was, our data was, from what we expected to see. So let's get all these values out first. So p hat was 51.6%, or 0.516. We know p naught is 0.5. That's what we expect to see. And q naught is just the complement of that, so 1 minus 0.5, which is still 0.5. And of course, our sample size n is just going to be the number of people we sampled, which is 500. So substituting all this into our test statistic formula, we get 0.516 minus 0.50 divided by the square root of 0.50 times 0.50, that whole thing all over 500. So now we just get our calculator out and calculate this value. So if we're using a calculator like Desmos, that makes it very easy to type in. We can just calculate it exactly as we see it. So on the numerator, have 0.516 minus 0.50. The denominator, we have the square root of 0.5, another 0.5, and that whole thing over 500. And there we go. We get our z-score of 0.7155. And I'll just round it to 4 decimal places. So what does this test statistic represent? Again, this is how far away our observed data were from what we expected to see. We saw our data fell 0.71 standard deviations above what we expected. So a little bit higher than what we thought, assuming this null hypothesis is true. So now, let's look at what we call the p-value. The p-value, again, is just what's the chances, what's the probability of seeing our observed data if the null hypothesis is true. We saw how far away it was, but what's the probability? So if we have a z-score and it's following the normal distribution, we can just use that, because we know that what we expect to see is the mean, but we got something slightly above the mean. We got 0.75155. And I want to know, what's the chances of getting something that far away or more extreme? Right? So how likely is it that we see something as extreme as what we saw here? So as we know this is a normal distribution, we'll just use a normal distribution calculator. So we can go into Art of Stat, select our normal distribution. We are looking at a z-score and we're trying to find a probability. So since it's a z-score, we are going to keep it at the mean of 0 and a standard deviation of 1. And as you saw, we shaded in the right side, so the upper tail, and we want it to be greater than 0.7155. And this would give us our probability of 23.72%. The area above is 0.2372. And so there we go. There is our p-value.